Okay, and finally number 5, if we look at this, it says there's a radioactive substance that decomposes in such a way that mass can be represented in grams after T years by this equation. Right? And so it's giving us the equation, except it's not giving us the base value. Okay? It then says after 2 years, the mass is measured to be 150 grams. Okay, and it's asking us to determine the common ratio for B. Okay, and so for part A, there's a couple different ways we can think about this. We can think about it just purely algebraically, and what that would look like is it's saying that if we put in the value of 2 into that equation, that the y value out would be 150, and the equation would be 2400 times b to the 2, or b squared. And so I have just one value, just b, and I can end up solving for this just directly. And so I would get 150 over 2400 is equal to b squared, and then I could take the square root of both of those sides, and I would end up that b is equal to 0.25. Or 1/4. And so I now have my b value, which is really great. That's sort of what I wanted to find. The one other way you could think about it is you could think about it this way, that we're starting out with 2400 grams. We're going to multiply by our b value once. We're going to multiply by our b value twice, because it's 2 years, and that's going to be equal to 150. Right? And so if I went to try this out, and I tried out a half and a half, after I multiplied by a half once, right, here I'd be at 1200, and then after I did it again, I'd be at 600, right? And so a half doesn't work. But if I tried a quarter, and a quarter, if I multiply 2400 by a quarter once, I get 600. And then by a quarter again, I would get 150, right? And so that works as my base value. And so just by using some, just our definition of what an exponential function is, this idea of repeated multiplication, we could figure this out without the algebra. So either of those two ways would be an okay way to find out what B is. And so we now know that B is a quarter. And part 2 here, part B, is asking us how much radioactive substance is present after 5 years. And so in B, right, this type of problem is sort of getting common. We put 5 in, we're going to get 2400 times 1/4 to the 5. Right, and we can then solve this. And when we solve it, we're going to get that it's 2.34 grams. Oops. 2.34 grams. That would be sort of what's left after 5 years. And then part C is asking us, how long would it take for the mass to decompose to half its original amount? Okay, so to half its original amount. So its original amount is 2400. And so half of that, right, half of that would be equal to 1200. Okay, so what this is asking us is we want a final value of 1200, and we know that's going to be equal to 2400 times 1/4 to the value of B. And what it's wondering is what is our value of B? Okay, and this is a little bit trickier to solve. It's actually one of the things that we learn logarithms for, is to solve exponential equations like this. That doesn't happen until grade 12, and so there's a couple different things you could do. You could do a guess and check here, right? And so a guess and check might be creating a table where you have B, and then you have your function m of B, right? And if you put in 1 for B, we'd take 1/4 of that, and we'd find out that we're at 600. right? So if we take in 1 for b, we're at 600. So we know it has to be something less than 1. Because if we go to 2, this would continue to get smaller. It's going to continue to decay. So if we try out 1/2, when we put in a half, what it's going to do is it's going to take the square root of a quarter, and it's going to end up being 1200. Right? And so by inspection, we really quickly found that in this case, sorry, I've been saying B here. This should be time. That should be time. So in this case, what we find is that when we have a time of 1/2, that actually, our mass then composes to 1200, and the units here are grams, which is half its original amount. So the answer to this would be 1/2 a year. Okay? And so one way you could do it is by guessing and checking. And hopefully you can do that and reasonably quickly get it down to a pretty good approximate value. The other way that you could do it is you could do it graphically. So this would be our guess and check. Right? And graphically is the other way that we could do it. Right? And graphically what we're sort of looking at is we're going to say that if I simplify this one more step, I can move the 2400 over, and I'll get 1200 divided by 2400 is equal to 1/4 to the exponent t, or I'll get 1/2 is equal to 1/4 to the exponent t. Okay, and when I get this far, I might notice that, oh, this is just the square root, so t must be 1/2. But if I don't, I can solve it graphically, and what I'm going to do is I'm going to take 1/4 t and graph that, right? And so this might be my 1/4 t, and then I'm going to take 1/2 and I'm going to graph that. And I'm going to be looking for that intersection. Okay? And in this case, it's going to happen at 1/2. And I'm just going to flip over to Desmos and just show you that. Right? Here we have our first function, the red function, is going to be y equals 1/4 to the x. And so that's looking like this. And then we also plot y is equal to 1/2. And what we notice is that those intersect at a t value of 1/2. So after half a year. Okay, so those would be the two ways that you could get to this final answer of a time is going to be equal to half a year. So C, it would just say 1/2 a year. Okay, and that is video number 5. I hope you guys have found these useful, and yeah, if you have any feedback, I'd appreciate it on what could make these better for you. Okay, thanks so much for watching.